Hi and welcome to this video. I'm going to show you our simulation of the BCI and our virtual environment which we have been making in RoboDK. This is also the video that is going to demonstrate the test 3 in the simulation chapter, which is going to undergo the entire protocol which is described there. This simulation has been made by group 465 on Aalborg University of the Robotics 4th semester 2021. Alright, so first of all you should be able to see the entire virtual environment on your screen right there. And this is a robot mounted to a wheelchair with a person sitting in it and also a table placed in front of it. There is no objects and so on that is able to be manipulated with because we haven't mounted a gripper or decided to use such. This is for demonstrative purposes only, so nothing to worry about there. Then we also have a BCI which is made in Python, and it looks like this. It consists of 5 boxes, which is in real life going to be blinking at different frequencies. And also we have a position feedback in the screen here, and also a gripper state, which is written here. So this BCI consists of 4 different sub-menus and 1 home button in this case. So we have the XYZ plus, XYZ minus, ABC plus and minus down here below also. And these sub-menus consists of multiple buttons. We can access this, for example. So we have X plus 1, Y plus 1, C plus 1, and the gripper in the middle. And then a return button down here in the right, back to the home screen, which looks like this. And to show that it's functioning alongside the RoboDK program, we have this image here, where you are able to see both the BCI and the RoboDK simulation in the right here, or in your left. I'm just going to zoom in to the robot here because it's a bit hard to see when you're zoomed out. And then lastly, you can see the robot joints down here below to verify that this actually works. So at first, the protocol states that we have to move the robot in the positive X direction a single time. So first we're going to access this positive direction in position regardless to XYZ. So we move the cursor on top of this box and then we enter the submenu. So let's try this like this. And then we would like to move the robot in 1 increment in the positive X direction. So this is done by just moving the cursor above this box again. And as one can see, there's an X1 here. The robot moved and the joint axis jog down here shows a 1 in the first axis. So this first part is a success. Then the protocol states that we have to move the robot in the negative B direction, or the 5th axis in the negative direction 3 times. So we're going to exit this submenu, and then we're going to enter into the ABC negative, because this is the negative direction we want to test. So we access this submenu and we take the B command 3 times. And as one can see, there's a B equals -3 here, and the robot moved 3 increments in the B direction. Lastly, the protocol states that we have to home the robot, just to prove that it is also possible to home the robot. And this is done by just simply moving the cursor above the home button, and this looks like this, and then the robot is homed. So that's the protocol which is described in test 3, and as it can be seen, every single button works. It's just the protocol describes these 2 features. We can, for example, use this Y plus 1 to see that the robot is actually able to move in the Y and also in the Z direction. And this gripper isn't actually attached at the moment, but it changes the gripper state, so you can see it's open right now, and we can try moving it there, and it's closed. This just goes on, and yeah, it works for all directions. So this is our simulation, and this is the test of the protocol described in simulation test chapter. Thank you for watching.